Next topic is discrete and continuous charge distribution. First of all, point charge distribution means a point charge is placed anywhere. Discrete means number of point charges are placed in a system. If this in this space number of charges are placed over here, this is discrete system. Now what is continuous system? Instead of at points, if this is a road, uniform road, and charge is continuously distributed, positive charge is continuously distributed over this road, then that charge distribution is called continuous charge distribution. Now, continuous charge distribution means charge is without any breakage is uniformly distributed over a system. So, what do we have? The first is point or the source charge. Second is discrete distribution of charge, means when in a system number of charges are present at different point. Next is continuous distribution of the charge, when charge is continuously distributed over the system. Here we can say this dq, this complete system on which the charge is distributed, that is say q. If I consider a small system of or small element of this say dq element and charge over it say dq, this is continuous charge distribution. Now continuous charge distribution is further of three types: linear charge distribution, surface charge distribution, volume charge distribution. Now first of all, let's come to for the continuous charge system, there is a key. First of all, rather than completing complete system, suppose if on this plain sheet a uniform charge q is distributed at every point. At every point, uniform charge is distributed. So on this sheet, everywhere where I colored it, charge is present everywhere over the sheet. Now, this is the sheet having uniform continuous charge on it, and it's completely covered with the charge. This is a plain sheet and this is the point P. I want to find out the electric field at point P due to this complete charge on this sheet. Now, what is the formula? What is the way over here? First of all, for continuous system, if we want to find out the electric field of this continuous system at any point in the given vicinity, first what we will do, first we'll find small element of charge. Small element of charge we will find, means we will find dq. After that we find electric field due to this dq, d. Once we find the electric field due to a small element, next what we're going to do, then we take integration of this. When we take integration, we get electric field of the complete system. So what we are going to do, for a continuous system, to find the electric field at a given point for that continuous system, first of all we find dq. Second, de means small electric field due to small charge element. Then integration, we will take integration of d. Then we will get the net electric field of the system. Now come back to the point. Continuous system of charge is of three types that we are going to discuss now. So first is line charge, second is surface charge, third is volume charge. Now line charge, it is represented by lambda. Linear charge distribution, it is also that linear charge distribution or line charge, it is represented by lambda. What is line charge? It is a total charge per unit length. Total charge per unit length, that is q by l, or we can say dq by dx. If we find dq, we get lambda into dx. Lambda into dx. No need to do this polar system. It's not in this syllabus. We just go for the Cartesian system. Cartesian means x, y, z plane. X, y, z plane. We are going to deal with that only. So, no. So, line charge is what? Lambda. Lambda is equals to dq by dx. So, dq we can say, if we take dx on this side, equals to lambda dx. We are not going to do this because this is polar form. We just go for the Cartesian form, that is x, y and z. And for the surface Surface is what? It is represented by sigma. Sigma is equals to charge per unit area, or dq by d. Now area is, if we are taking xy plane, if we are taking xy plane over here, this is x, this is y plane. For that, area is dx dy. If we take yz plane, then area would be dy dz. If we take xz plane, then area would be dx dz. So dq equals to sigma of this. So volume charge is represented by rho. It is represented by rho q by v, that is dq by dv. So it is given by this. Now dv is equals to dx into dy into dz. So next is electric flux. Now I think so you are clear with the topic of what is point charge, discrete system of charge, and continuous system of charge, where continuous system of charge is further divided into three parts: linear, surface, volumetric. Now next topic is electric flux. Electric flux. Now what is electric flux? It, as we know, we represent electric field by imaginary lines which are called electric field lines, and the properties of electric field lines we already had discussed in the previous video. Today we are going to do about what is electric flux and surface area. First of all, electric flux. It is a number of field line crossing a given area. Suppose what we have to take here, this is area. Suppose we take a plate over here. Now from, or we, if we say this is a frame, and from here flow of water is there. Now how much water is passing through this flow is called water flux. Is called water flux. Similarly, if this is the area, electric field is passing through this area, then how many number of field lines passing through this area, that is called electric flux. That is called electric flux. That is number of field lines passing through a given area. If number of field lines passing are more, then electric flux will be more. If number of field lines are less, electric flux is less. Now electric flux is given by a formula E is equals to, or sorry, electric flux, it is denoted by phi E. Flux is represented by a symbol phi. If it is electric flux, it is represented by phi E. If it is magnetic flux, then it is represented by phi B. We'll discuss it later. But right now we are discussing about phi E, that is electric flux. So electric flux, that is represented by phi E, scalar quantity it is. Its formula is amount of electric field passing through a given area. Now I am considering area as an area vector. Area vector. Now what is area vector? I know you know all about area, but area vector, it is a term new to you all. Now let us first discuss about area vector, then we'll again come back to this formula to discuss it further. First of all, area vector. Area vector. Actually, this is a vector form of area. Vector form of area. And to represent the area, we require what? Magnitude plus direction. We require this magnitude plus direction. Now, area vector, magnitude is simple area. Whatever the area, that is the magnitude. Now, what is direction? How we can give it a direction? We give it a direction by n cap. Here, n cap gives the direction to the area vector. Now, what is n cap here? N cap is, it's a normal drawn outside of area. Suppose this is a cube. This is a cube. This is, take this side of the cube. Now for this area, outside direction is this one, this is inside direction, this is outside direction. If I draw a normal means 90 degree to this area in outward direction, this gives the normal of this area, that is n cap. For this face, if I take a normal in upward direction, this is outside. If I take it in downward direction, that will be inside. So outside, so n cap is what? N cap has two conditions. N cap is normal. First, it is normal to the surface. Normal to surface means making an angle of 90 degree. Second, it's always drawn outward from a surface. Surface. Outward means always in outward direction. So again, so area vector is magnitude of area into normal. So when we come back to the formula, flux phi E, that is equals to E dot ds over a closed surface. So flux is always through a closed surface. So E dot ds, so it is, if suppose this is surface, for this is the normal n cap, and this is the direction of electric field which is passing through this. Suppose electric field is making an angle theta. So phi E equals to E dot ds, where ds is equals to what actually? E dot ds n cap, where ds is only a magnitude, so we take E dot n cap ds. So we have an angle between E and N, that is cos theta here. So phi E is equals to integration of E, magnitude of this n cap is to be 1. We know for every cap quantity we have a magnitude of 1. Magnitude of E is E, 1 is 1 into cos of theta between them into ds. So we get here phi E is equals to E ds cos of theta 1. If angle between them is 0, means if E is in this direction, n cap is also in this direction, then angle is 0. This quantity become 1, so we get E ds. Sorry, E ds only after substituting the angle. But if we have an angle in generation in initiality, so phi E is equals to integration of over closed surface E dot ds. So this is the formula of electric flux. This is the formula of electric flux. Now let's go to the Gauss theorem. So let's cover it. Electric flux, it quantifies the notion number of field lines crossing a surface. So electric flux phi through a flat surface in a uniform electric field depends upon the strength and the surface area and angle between them, because phi is E A cos of theta. More E, more A, more theta means more the flux through it. So A is the area vector whose magnitude is A and whose orientation is normal to the surface and is always in outward direction. Now next is Gauss law of electrostatic. Now comes to the Gauss law of electrostatic, most important topic of this unit. Gauss law in electrostatic or Gauss law of electrostatic. What it states? Now Gauss law of electrostatic state that electric flux through a closed surface is equals to 1 by epsilon naught times the, once again I'm repeating, electric flux through a closed surface enclosing a volume V is equals to 1 by epsilon naught times the charge enclosed in the system. So phi is equals to Q by epsilon. So according to the Gauss theorem, phi E is equals to Q by epsilon naught, where Q is what? Q is total charge inside a closed surface. Inside a closed surface. What it means? If we have, this is a surface, this is a closed surface enclosing volume V. This is a surface enclosing volume V, and total charge in it is 4 charges are there: Q1, Q2, Q3, Q4. Now total charge in it is Q1 plus Q2 plus Q3 plus Q4. Now, according to Gauss theorem, electric flux through it is equals to 1 by epsilon naught times the total charge enclosed by it. Now, total charge is what? Q1 plus Q2 plus Q3 plus Q4 upon epsilon naught. Now, if total charge enclosed by the surface is a charge Q is present in the surface and charge minus Q is present in the surface. Now, total charge is equals to what? 0. Total charge is what? 0. Q plus Q minus Q, that is 0. So, total flux is going to be what? 1 by epsilon naught time of 0, that equals to what? 0. So, flux through surface is 0. This is in mathematical form that flux through this surface is 0. But what is actually physical significance of this? If a surface containing equal positive and negative charge in a system means due to this positive charge, electric field is in outward direction. Due to this negative charge, electric field is in inward direction. It means what? Total flux leaving the surface and total flux entering the surface equal. So net flux through is 0. So phi exit equals to phi in. So net flux through the system comes out to be 0. So what is the define of electric flux? Electric flux states that surface integral of electric field surface integral of electric field over a closed surface enclosing volume V is equals to 1 by epsilon naught time charge enclosed, total charge enclosed by the surface. So again I'm repeating, the surface integral of electric field over a surface integral of electric field, surface integral of electric field over a closed surface is equals to 1 by epsilon naught time total charge enclosed by the surface. So this is the define of Gauss law of electrostatics. The surface integral of electric field produced by a source over a closed surface enclosing V in vacuum is equals to total flux over a closed surface is equals to 1 by epsilon naught times the charge enclosed inside the surface. So phi E, one formula is this, other formula is this, so both are equal. Now next is verification of some, let us discuss about some essential properties of Gaussian surface. So what is, first of all, let us consider what is actually use of this Gaussian surface. Why we are taking this? What is the use of the Gaussian surface? Why need to do this, or what we have to do with it? As we all know, Coulomb's law can be used to find force, and from that force we can find the electric field by using the formula F by Q. So electric field can also be calculated by using Coulomb's law, but there is a limitation that this formula is valid only for point and discrete charges. Now for what about the continuous system? For a continuous system, if I am willing to find electric field, then what to do? Coulomb's law is not valid. Then where we have to go? In that case, we have to follow Gaussian law. Now in Gaussian law, we use Gaussian mathematical form, that is phi E is equals to E dot ds Q by epsilon naught. We use this mathematical form. But what actually Gaussian surface is? How to choose a Gaussian surface? How we can choose a surface which is Gaussian? First of all, let essential property of Gaussian surface. First property is it should be closed surface, so that clear distinction can be made between the points that are inside the surface, on the surface, and outside the surface. Like if we consider, if this is a system of continuous charge, a road is there on which positive charge is continuously distributed or negative charge is continuously distributed. Due to this road, a point P, here I want to calculate the electric field. Now I used to do what? I will draw a Gaussian surface which enclose this road. Or if I want to find electric field due to a sheet, Then I will at point P, then I will draw a Gaussian surface in such a way that it will pass it through this point and enclose this. Now what we have to do for that? What we have to do for that? First of all, for a system to be Gaussian means we have to choose a Gaussian surface to apply Gauss theorem. So first of all, to apply Gauss theorem anywhere means if we want to find electric field for a continuous system, first step is what? If we want to find electric field for continuous system, first point is what? We know we can use it, we can find it by using Gauss theorem or Gauss law. But how? First step, you have to choose a Gaussian surface. Second point, by choosing the Gaussian surface, you have to find the charge. What is the charge enclosed by it? And then you have to using this formula E dot ds q by epsilon naught. You can calculate by solving it net electric field. Or otherwise, if you know phi, then by using phi is equals to 1 by phi is equals to E dot ds by using this formula. Again, you can E. Means final term that we have to find E. Either using this formula or this formula. But first we need to have a Gaussian surface. Now there are some essential conditions while choosing a Gaussian surface. First of all, Gaussian surface is needed to be a closed surface. Second, it must pass through a point P at which we have to find the field. जिस point पे field find करनी है वो उसमें से pass करे, वो closed surface हो. It must be symmetrical. Symmetrical means what? If I take this rod, due to this I take a cylinder. To find electric field due to this rod at this point P, I will choose a Gaussian cylinder as a Gaussian surface. This is symmetrical because if I cut it from the center, on this side whatever the charge is, on this side charge is same. If I cut it laterally like this, then on this side and this side charge is same. So it is symmetrical. So longitudinally and laterally a system must be symmetrical. Now a Gaussian surface can be spherical, cylindrical, cubical, depending upon the system of charge distribution. Like if there is a point charge or there if a charge is distributed over a sphere over the surface, in that case if I want to take a Gaussian surface, that must be a spherical. If a line on which positive charge is distributed everywhere, we have to find a field, in that case cylindrical it is. If a plane sheet is there, even in that case it is to be cylindrical. If it's a plane sheet over there, in that case also it should be cylindrical. It should be cylindrical and symmetrical. So different type of Gaussian surfaces are there. We choose according to our need. So first property is it should be closed surface so that clear distinction can be made. Keep which point are lying inside and which point are lying outside. Surface must pass through the point where electric field is to be calculated. Like if point P where we have to find the electric field, that point must be on the Gaussian surface. Third, the surface must have a shape according to the symmetry of the source so that the field is normal to the surface at each and every point and constant in magnitude. Now symmetrical means one more thing. First of all, field it's required to be normal at every surface and it's constant in magnitude. So next is verification of Gauss law. We are going to verify Gauss theorem. So Gauss theorem is this, as we already know, that is equals to 1 by epsilon total charge enclosed by a system. Now proof of the Gaussian system, Gaussian theorem. First of all, we start with this left hand side. We start with the left hand side and we have to find this right hand side result. So if I start from here, we want to find this result. If we get this result, that means this law is verified. So let's start. So we start with this as phi is equals to E dot ds. Now, first of all, what I'm considering here, spherically symmetric surface. For a spherically symmetric surface, charge is distributed all over the surface. And I choose a small element ds, I have chosen over here. So the small element ds, what we have taken, phi is equals to E dot ds. Electric field formula is again for a, as this all appear to be a point charge at the center plus q. So formula is 1 by 4 pi epsilon naught q by r square. This is the distance between these two point and center, r square. R cap for the direction, r cap is in outward direction, and ds is the surface and its normal is also in outward direction, n cap. ds n cap. This is E ds. Now 1 by 4 pi epsilon naught q by r square r ds, this all could be common, r and n both are in same direction, so angle between them is 0, cos 0 is 1. So we get what, d phi is equals to 1 by 4 pi epsilon naught q ds by r square. Now we have to calculate complete phi. We'll take integration of it. When we take integration on both sides over a closed surface. 1 by 4 pi epsilon naught common, q is common, r square is constant. These complete terms are constant. We take outside. So inside we left with integration of ds. For a spherical surface, integration of ds means surface area formula is 4 pi r square for a spherical surface. So it is 4 pi r square, substitute the value, r square get cancelled with r square, 4 pi with 4 pi, we left with what, q by epsilon. So we started with E dot ds and we get the result what, q by epsilon. So we can say Gauss theorem or Gauss law is verified. Gauss law or Gauss theorem is verified for a spherically symmetric surface. Spherically symmetric surface. That's it.